Welcome to the September edition of Mytech U, where today we're going to talk about wireless for business and how to make it work. I love this topic, and I'm thankful that we've got a wireless expert, Philip Holt, on to present it today. And I want to thank everyone that's listening for joining. Please, throughout the presentation, use the either raise your hand and there's some comments, or use the questions pane. And I will be monitoring the questions as Philip is presenting. I'll either answer them offline, or I'll interject them into the presentation, so please interact. But wireless is one of those things that sometimes it can be really simple. You know, you go down to Best Buy and you pick up a little $50 wireless access point, or it's already built into your cable modem that you get from Comcast or Time Warner or some other cable provider. And that works great. But then once you start throwing lots of devices and lots of people in a small space, then it gets exceedingly complicated. And so that's about what we're going to be talking. That's what we're going to be talking about today, which is wireless for business. And in the last few years, the proliferation of mobile devices, tablets, laptops, phones, smartphones, all of them are trying to connect to wireless, and it's creating a real problem. And so today we're going to talk about why those problems exist, what do you need to do to help plan for them, and help you out with a questionnaire towards the end that we can go through depending on how much time we have. So with that said, I'd like to introduce Philip Holt, who many of you probably are aware of. He's our CTO, CIO. He's our chief technical. He's our lead technical person here on the sales engineering solution architect side. He helps with designing a lot of our solutions and vetting our vendors and the technologies we use. And he is going to lead us through how to make wireless for business work. So Philip, please take it away.
Absolutely. So I'm really excited to be here. This is something I feel it's a piece of technology that I really enjoy talking about. And just to kind of go over what we're going to be talking about, we're going to go over a really high-level overview of how wireless works. And when I say high, I mean real high. We're just going to get some terms down. Then we're going to talk about some of the key variables associated with deploying wireless. And that's going to include the fact that there are business requirements and there are technical requirements, and there's a relationship between the two, which is kind of the meat of what we're going to talk about. And then we also have a wireless network questionnaire that is going to provide a guideline or a framework in order to help different businesses or organizations identify those factors that are of concern for them and when they move forward with creating or deploying and designing a wireless network for their business environment. We're just going to jump right in here, and we're going to talk about some of the kind of what's in and what's out, the purpose of this conversation. I have a diagram up here, and what you're going to see is that we've got some stuff in blue and we got some stuff in gray. These items in gray represent our standard normal wireless wired network before we introduce wireless solutions. And what we'll see is that we have endpoints and we have desktops. We have an existing switching infrastructure, firewall infrastructure, and we have different types of data that we need to connect to, whether that be internet or other data. When we introduce the wireless environment, we're talking about introducing different types of devices that are going to connect through a wireless access point. But the key point here is that the switching, firewall, other data, internet, all needs to exist. So we're presuming that there is that infrastructure exists at this time. But the consequences of how the switching is configured and the firewall is configured plays into the deployment scene. So a little bit what we're talking about, just to kind of, again, clarify, when we're talking about these devices over here on the left, we're talking about those devices that might access the wireless network. And we have tablets, we have laptops, or very traditional types of devices. But oftentimes we see more and more, we may have folks with smartphones. There may be a warehouse environment where we have wireless scanners that need to access the network as well. And then we have our access point, which is often referred to as the infrastructure portion of it. Sometimes people consider the access point to be part of the switching, and in fact some vendors incorporate those two together. But technically they're really kind of separate modules. The access point is really going to be more of a bridging infrastructure that's going to connect us into our switching infrastructure. And that's a technical distinction that we'll bring up a little later on. So I have this diagram here available, and we can certainly talk to it and talk to it more should other questions come up regarding that. To move on here, I want to talk about when we talk about wireless. Oh, I'm sorry.
Just interject one little quick point. Forgive me, I just thought of it. Is that oftentimes when people they talk wireless, it's wireless. Well, there are wires involved, when you're dealing with wireless. And like the wireless access points have to be physically connected to the rest of your infrastructure. There is a wired component of this, and that's something that minor detail. Most people probably already know that, but it's definitely something that has come up in conversations that I've been a part of, where there was some realization that, oh, the wireless actually does need to be physically wired to the rest of the infrastructure. So minor point, but I just thought I'd throw that in there as a last comment there.
Sure, and absolutely, and that kind of underlines the point of what I was talking about here, is that the access point is only part of the issue. What the business objectives we're going to talk about is getting this tablet access to this internet or this data, and the wireless portion is only part of that route that data needs to traffic. So we're going to be focusing primarily on the parts in blue, with an understanding that there are still firewalling and switching and routers and internet providers and things like that that need to be available for the endpoint. But good point, Nathan. Want to go over some business requirements or some business objectives with regards to identifying what wireless needs your organization may have. There are many considerations, but the kind of key four that we can look at are identifying the coverage that is required. When we talk about coverage, we're really talking about the building in the space. Is there one building? Is there two buildings? Is 4,000 square feet and only the warehouse needs access to things, or is it there a guest area where we want our visitors to be able to access the internet, or what is the physical topology of the buildings and the places that we need the coverage look like? We have a desired use, and this is really key. It seems the concept behind networking in general and wireless networking specific, it seems very simple in terms of we want to just be able to connect, and once we connect, there's a presumption that we can do anything we want. With wireless, as we'll see, there's a lot of interdependencies regarding the technology behind what type of data we're accessing, and so understanding the desired use is really critical in designing the right solution. There's a different infrastructure that's going to be in place if we're just going to provide basic web browsing, or if we need applications that need to be on all the time with a steady, constant connection like a remote desktop connection, or perhaps we're in an environment where we need really high bandwidth. We're going to be streaming video content to multiple users, perhaps in an educational environment. And then there's a use case that is on the horizon and appears, from my perspective, to have been perpetually next year away. We're not quite there yet, but the concept of just replacing all the wiring in our building with a wireless infrastructure. So we'll talk about that. Certainly a desired use and can be implemented, but it gets very complicated in terms of understanding how and why that's going to happen. Other business requirements to be considered are the security. Really, we're talking about providing people access to content and understanding who can access that content or that data and infrastructure, and who else can see who's accessing it. So we're used to, on a wire, once I'm plugged in and I'm on my computer, we kind of trust that the piece of copper that runs between my computer and the servers is more or less impervious to folks unless they're getting really digging into the walls and pulling out my wires. But when we're talking about a wireless medium, anyone can be listening to the same wireless traffic that I have. And so understanding the safeguards we can put in place in order to make sure, even though they may be able to see the wireless signals, that they can't see exactly what I'm browsing. There are some environments in which this isn't very important. Any kind of regulated environment, we're talking healthcare, or we may be dealing with personal private information. And there are other instances where it's not as important if we're talking about simply providing web browsing access for folks. And the final kind of category of business requirements that I like to discuss are the device types that are accessing it. In an ideal world, the wireless environment that we present to our users is really doesn't care what type of device we're accessing from. But unfortunately, because of some of the limitations we'll see moving forward here, whether or not you're accessing from a laptop, a tablet, or a smartphone can really make a difference in terms of what the infrastructure looks like. So all of these different devices have different characteristics and different requirements that need to be fed and met by the wireless infrastructure that we're providing them. Nathan, since you've been listening in, do you have any kind of examples or comments you want to add on these kind of base business requirements that we've have here?
No, I think it'll be best applied in the further pieces. So no, I'm good. Thank you.
Great. So we have its business requirement map, but then sometimes we have people in our organizations that are more on the technical side. And so there are technical considerations that we need to have when we're discussing the wireless networks. And so we oftentimes see things like signal strength, throughput, encryption, channel, frequency, WPA. A lot of acronyms get thrown around, and what does that all mean? Well, these are technical requirements that need to be understood and need to be designed appropriately to meet the business requirements on the previous page. So I want to go over a little bit, provide a little bit of technical context inside of what each one of the items I have here on the screen is about. And certainly, you know, I love talking about this stuff. So if anyone has any further questions or wants to chat more, please reach out to us either through the chat window or with an email after the presentation. And I'd love to go over more and explain more to you as we can. So signal strength in the technical consideration has to do with the how loud the wireless environment is to the device that is accessing it. So when I have my laptop or my smartphone, there's a certain volume, if you will, if we were to use the analogy of someone speaking in a room. There's how loud I can hear that person, and then how loud they can hear me when I speak back. And the two devices, both the access point and the device, need to be able to hear each other at a sufficient volume that they can communicate and continue to pass data back and forth. And that signal strength is determined by a number of different factors, but ultimately it's defined by physics. So we have various factors that may come into play. For example, the physical distance between the access points and the people accessing the data, whether or not there are walls in the environment, or those walls are made out of stone or glass or simple drywall. What does the environment look like with regards to other types of devices that speak in the wireless spectrums? So we have microwave ovens or Bluetooth headsets and things like this can all affect that signal strength. And unfortunately, it's a really simple concept to understand, that I need to be able to hear what I'm talking to. But it's really, you can't see it because, of course, we're talking about wireless stuff. And these signal strengths are best modeled with using specific tools, which can either be predictive in nature, where we draw a map and we use some fancy math to try and guess what the signal is going to look like once we put devices in, or we can, in fact, put some temp devices in and then test to see what the actual results are. So these are parts of a wireless survey, which is generally required in the case that we're going to be doing a complex wireless deployment. We need to understand what the signal strength, propagation, and interference looks like. If we move down to the
so Phil, just to talk, to throw that in, I know that just to reiterate as you're going to go on to the next step, but where this plays in, there's also you'll hear things, and I know Phil's going to talk about the channel and frequency. It's really as you you might have this is kind of probably the bars that you see on your phone as far as being a signal strength, and there's also difference between Philip gave a laptop and a smartphone example, and I think the point that I know maybe you're going to make this later, Philip, but I know that that people sometimes will experience where your laptop might connect just fine, and your smartphone's in your hand, and you're sitting in front of your laptop, but yet your smartphone doesn't get as good as a signal. And it's not because of the volume of the access point. Both devices can hear the access point, but the smartphone has a lower volume communicating back, and so it doesn't have as strong of a signal going back. So your laptop has a stronger signal than what your smartphone does. So there's some of the ways where that signal strength, even on different devices, and that's where the complex physics come into play, right? Is if there's a lot that goes into just even something as simple as the signal strength. So just to throw in another comment.
Absolutely, that's a good point. Is that what we're going to see later on? Is the signal strength is a simple concept, but it's driven by a lot of different things. It's driven by the physics. It's driven by the access point. It's driven by the type of device that's accessing it, and it's also the channel and frequency that we're using as well. I think that's a good point, Nathan. The throughput is another concept that is oftentimes overlooked. We have a concept of once I'm connected to my wireless network, my speed is I have the connection, and then I can go ahead and do whatever I want. However, there's a finite capacity to any wireless network as with regards to how much data it can move at a time. And the key point on here, which if I had had more room on this sheet I would have called out, is that from a technical perspective, a wireless network is a shared medium, meaning that the people who are accessing it all have to share the same wireless frequencies within reason. And so that 2 people using the network versus 10 people versus network, all of the people participating will have their experience degraded and the amount of data that can be passed through the network degraded by the number of people that are on. So we really need to understand how much data is passing through, whether we're doing some very simple remote desktop access or if we're streaming videos. And the use case really drives that information. Encryption and authentication are the next step of one of the technical considerations. And this is based, there's a lot of acronyms that get thrown out there. This is where we hear acronyms like WPA and WEP and shared key and SSIDs and these sorts of acronyms. And what all those acronyms are referring to is the fact that there are a variety of protocols and standards that have been created in order to ensure that devices and access points can talk to one another. And the key point here is that there are every day or every year, there are new protocols and standards that come out. However, the devices that are already in the wild, so to speak, may not yet have access to those. So we also need to understand what are the current levels of encryption and authentication protocols that are available to us, and what are the limitations as to what we can use. It's kind of a base example. The original encryption standard, which is called WEP, was very quickly proven to be entirely ineffective. And so the organizations that came up with further authentication methods that increase the type of encryption and the method of sharing keys. There are also very important considerations here in terms of what is deemed secure enough. So once someone gains access to a wireless network, depending on the protocol and standard you're using, they may or may not be able to hear and understand what other people are doing on that network. So understanding those use case requirements is pretty important. And picking the right encryption and authentication method may, in fact, require external factors. And this is a key when we pull back to that first slide about the infrastructure that's presumed to exist. We may have to perform different types of segmentation with regards to firewall and switching and username and password-based accesses in order to ensure that we are both encrypting the data for protection and then also authenticating it to make sure that the folks who are accessing the network are the people we want to access the network. Technical considerations involved with regards to channel and frequency. Provide a little information as to exactly what we're talking about here. The governing body in the United States, the FCC, dictates that there are certain radio spectrums that people can use without getting permission, so-called unlicensed bands. And currently within the wireless community, we basically have 2 bands that we're working with, and that's in the 2.4 gigahertz and the 5 gigahertz range. And when we say range, that's key because we talk about 2.4 gigahertz spectrum or range, and that's really a bottom and top frequency. So not only is there kind of a channel to dial into, but there's also a width and the total amount of data that can be pushed over that. And each one of those individual frequency bands that are licensed by the FCC are broken up into multiple channels with respect to Wi-Fi. And we have technical considerations we need to take into play when we decide which channel and which frequencies to use. Some of the major players involved here is that those frequencies that tend to provide us the best signal strength and the best distance happen to provide us the least throughput and the least density. So understanding the relationship between the channel selection, the frequencies that are available, the signal strength, and the throughput is all really critical to meeting those business needs. And
I don't know, just to throw out on that, Philip, I mean, the other thing that comes into play is when you talk about signal strength and throughput, if anyone's who has either deployed wireless or you've got a multitude of different devices and legacy devices that older devices, older mobile devices in particular, are more inclined where they only have a 2.4 gigahertz radio in them. So it's not only a consideration to meet the business requirement of your coverage and density and all that, but it also means you might not be able to only use a 5 gigahertz spectrum because you might have devices that are legacy or older devices that can only use the 2.4. So that's definitely a variable that gets thrown into the mix as well.
Absolutely. And again, that there are the second point of the channel frequency is that there are very significant external factors that we cannot control. Physics provides us the basic principles in which we need to design our channel and frequency mappings. However, real-world factors come into play. As an example, if you've ever been in an environment where you opened up your laptop and you saw 32 different wireless networks you could connect to, that's an environment which is going to be very challenging from a channel and frequency basis. Those environments where there's lots of existing wireless networks, very careful planning needs to be made, if it's even possible, in order to skirt around, to kind of abuse a phrase, those other folks who may be using the wireless. And again, the selection of channel and frequency is really going to be dependent on what our external network looks like, what our signal strength requirements are, and what our throughput looks like. And sometimes it's just out of our hands, and we have to deal with what we're presented with.
So let's give a couple examples. I know an example that when you talk about that environment where you've got like 30 different SSIDs available to you, I've heard an analogy used that for folks that are listening in right now or listening in later, as this is a recorded session, that it's kind of like if you ever remember dialing your old radios, right? Where you'd be on one station, you get a clear signal, and then you kind of start dialing. It doesn't automatically just switch to the next one. You dial between stations, and then you kind of hear static, and you might hear a little of the station that's nearby and the station that you're just past. But that's kind of what your devices hear when there's all this signal, this just abundance of signal with the different wireless devices chatting. It creates noise. So what you might experience and what you might see on your device is, oh, I've got full bars, right? Or I've got my 3 or 4 bars on my wireless device. I've got a good wireless signal. But what your device is actually hearing is this static between stations. And of course, if you think about that static being the inability to actually transmit data effectively, which is really what it is, then that's what you experience, even though to you visually it looks like you've got full signal strength. I don't know, Phil, is there any comment or elaboration on that?
Sure. Let me actually, if we have time here, I'll make a brief analogy that is not perfect, but I think effective to discuss the channel and frequency. If you imagine a room with more than one person in it, and let's say that one of those persons is a presenter of sorts or a moderator, and they're talking to a bunch of people in the room, as long as there's one person talking and lots of people listening, or there's one person who's moderating in charge of that conversation, they can speak and everyone can understand what they're saying, and if someone wants to interject and ask questions, they can ask questions back to that person leading in the room. But if we start having more than one person talking at the same time in that room, and I'm sure you've been in that environment, this is the kind of cocktail party effect, you can understand, as long as you're listening in really carefully and you're deciding you want to listen to speaker A as opposed to speaker B, there's a point up to which they can both talk at the same time, and you can both understand, people can be listening to either speaker and still understand what each person is saying. But once there gets to be 20 speakers and 100 listeners, it really drops into chaos. And the only way people can be heard is to start screaming over one another. And that's where we get the channel and frequency congestion, and that's the environment that we face when we open up that Wi-Fi connector and we see the 20 different networks.
Yeah, no, that's good, Phil. Thank you for that. The other thing on this page, I want to give some other practical examples of, when you talk about kind of the signal strength through, it's kind of the density question. I was at a conference just a week ago today, and it was a technology-based conference down at the Thrive Into Financial Center downtown Minneapolis. And at the very beginning of the session, there was about 300 people there, and they said, this is a technology conference, so we want you to use your smartphones and iPads. So the presenter at the beginning said, hey, everyone, get out your smartphone and iPad. I want to make sure everyone has access to the wireless that we have in place for the conference. And he literally, about 300 people, all at the same time, tried to connect to this wireless. And this gets into some of the problems that we're talking about with business and this congestion, is that it's also about density, and that I was able to actually connect. So I pulled up my smartphone, I actually connected to the wireless, but I couldn't even send, and they were also encouraging people to tweet. I actually sent my very first tweet at this conference. But they were encouraging people to tweet. I couldn't even send basically a simple text message over the wireless because there were so many people connecting all at the same time, clogging up. Even though my phone said I had signal, I couldn't actually even send a basic text message. So, Philip, I don't know if that kind of gets into the throughput and signal strength and density. I don't know if you want to elaborate on that, or maybe that sets up your next slide. I'm not sure which, but I just throw that out.
I think that ties well into the analogy I was providing before of that presenter in a room. When there's one person talking and lots of people listening, if that environment is one person talking and 7 people participating in the conversation, and the presenter invites people to just shout out questions when you have them, that can work in a small environment when there are a few people. But if we are in the environment where you or Nathan, where there were hundreds of people, and if you imagine a speech, someone giving a presentation, and they just invite the room of 400 people to just shout out their questions whenever they have them, it's going to go badly pretty quickly. And so having a good moderator and a good system for understanding who gets to talk when and where is really key as the number of people and the amount of throughput and the different types of devices converge together on a single wireless network. So when we talk about selecting the right wireless technologies and access points and infrastructure, it's really about creating that moderator system and identifying how can we make sure that everyone is heard and everyone gets to say what they need to say inside of this context and the limits of physics.
So thank you for that. Now I have another example that I want to give that I think will speak and allow you to elaborate kind of on the throughput. So let's use that same example of being in a room of 300 people. Again, this happened last week to me personally, and I talked to several other attendees, and they said, yep, I experienced the same thing. Well, what if, let's say everyone was connecting just fine because the solution was designed in such a way to allow all those people to connect and communicate, no problem. Well, also, what actually happened just recently, it didn't happen last Wednesday, but what did happen recently for anyone who has an iPhone is that the new iOS 8 is available, right? And that pops up on your iPhone and says, hey, do you want to download this now? Well, if I'm a single user amongst 300 people and I say, yes, I want to download the new iOS 8 app or the new update for iTunes, what might that do to the wireless network, Philip?
Well, in that case, I would look at we'll come back to the concept of it's a shared medium, and everyone has to share a finite amount of bandwidth. So there's a finite amount of information that can be traversed either in one direction or the other, and everyone has to take turns speaking. In the electronic and wireless world where things move at the speed of light, we can take lots of turns in a really short period of time. However, there's still a finite amount of information that can be traversed. Another analogy may be that if you have another example of a shared medium that we're probably all more familiar with is if you have a single internet connection that everyone is sharing, you know that if you could be one person using the internet and have a wonderful experience and be able to stream your videos and get your content and have a great experience on your internet. But if you had 100 people or 50 people sharing that same internet connection and they all want to watch a video at the same time, everyone's going to experience poor video and have a poor internet connection experience. So in the example of an internet connection, we can provide more bandwidth on that internet connection so we can fix that problem. In wireless, we have some tools to try and do similar things, but ultimately, again, we're limited by physics and how much information can be transmitted at a given time on those frequencies that the FCC allows us to use.
Yeah, thank you, Phil. And that's kind of the point that I was going for, is that if you're considering offering guest wireless access, for instance, be aware that there are tools that you can put in place so that your guest access doesn't impede or your with your other business traffic, or your business traffic can at least take priority over your guest traffic. The other things you can do is there's tools in place where you can actually throttle the actual amount of bandwidth in the individual device gets. So if you only have X, like Philip said, there's a finite amount of bandwidth available. Well, you can actually design it into your solution if it's appropriate, so that devices only get a certain amount of bandwidth. So that someone choosing to download, their iTunes, or choosing to download the new iOS app, or choosing to download some other large file or large stream, it can at least have a minimal impact, or you can mitigate the impact that it's going to have to everyone else in the environment. That was kind of the other piece. So thank you for pointing those things out, Philip. Last thing I do want to point out, because I think this is oftentimes overlooked, and this doesn't necessarily apply just to wireless, but I think it becomes more of an issue in the wireless world, and that is content filtering. Now, this can be employed either sometimes at the access point level, or potentially at the firewall level for your environment. But imagine that if you are in an auditorium, or it could be a church pew, or it could be a restaurant where you've offered guest wireless to whoever is attending those respective facilities, and you got someone that pulls up their iPad or their other tablet, and they're browsing the internet, and all of a sudden some adult content website pops up on their iPad. Now, that person that's using an iPad might not be the problem, but little Susie sitting or standing behind that person that sees that content could be a real problem for you. So that's one of the areas where the same type of tools that allow us to throttle from a throughput perspective are the same type of tools, or similar type of tools, that can make sure that you enforce and filter the type of content you will allow get through to someone's smartphone or tablet or laptop, such as adult content, gaming, things that might either impede the throughput, or that could actually cause other problems from either an HR perspective or a liability perspective. So something I always like to point out when it comes to this kind of stuff.
Yeah, I think that's a great, I think you're kind of starting on some great segue to move on to some of the other slides I have here, which I'll try and get through pretty quickly, because I want to make sure we have an opportunity to go over our questionnaire and provide an opportunity for questions as well. So basically what we've been seeing here, we're talking about as we've been kind of rambling through, is that there's a desire to simplify things in the world, and we want to be able to say that addressing the coverage requirement is as simple as identifying what the signal strength needs to be, and identifying the desired use is as simple as identifying what the throughput needs to be, and so on through these other business requirements. But as Nathan's been discussing and mentioned that, and we've been talking around, is the idea that all of these concepts are interrelated, and that if you're talking about what you need to do to provide appropriate coverage, that may very well define what channels and frequencies you need to use. And if we're talking about what type of device type that we may need to be accessing, that may limit the type of encryption and authentication methods we have available. So this is kind of the slide intended to confuse you, but what I want to present here is this simple question, and even though you may be able to define what your coverage requirements are very simply with a few words, the technical consequences of each one of the business requirements you have does not align nicely one-to-one with the technical considerations that we have to make. So designing a solution strictly for coverage or strictly to be secure doesn't give the whole picture, and is quite likely to result in a poor experience with the end product. We've talked about kind of these 4 different business requirements, and I've talked a little bit about some of these technical considerations. And again, I could go very deep into detail of these. If people have more questions or want to understand some more of this nerdy stuff, feel free to ask some questions, and we'll be happy to reach out and get you more information. But
so I do have a question around that, just to kind of poke and to give you, so different solutions out there. So these are the problems that are the reality of the problems we need to deal with, right? That in order, the complexity that's around deploying a wireless solution, and different providers have helped solve this, have approached solving this problem differently. And I guess this is, maybe there's an opportunity to talk about how, some access points that you can buy that are enterprise class might only have 2 radios, but they have and they use a LAN controller to help with that. I think of Cisco access points for as that example. And some access points or arrays, Xeris uses a different methodology, which they use kind of cell phone tower methodology, where they can put up to 16 radios in a given array to deal with the flexibility and the complexity of wireless deployments. And there's pros and cons to both. I don't know if you might be able to speak to, maybe a little bit of the way that the difference between, why going down and buying a Linksys device. What are the things that, like, say, a Linksys or D-Link or Netgear, some of the things that you buy for $50 or $100 on a Best Buy? How does the enterprise deal with some of those things differently, just at a high level, relative to helping solve these problems?
Sure. So your consumer-grade devices that you're going to acquire are really, they're essentially trying to balance all these factors for you. And so they're going to really focus on providing the best signal strength with some consideration as to throughput and security. But in general, they're really optimized to do one type of environment, which is one or two people inside of a house. And they presume a clean environment. They presume there's a lot of interference around. And so again, the basic technology in terms of when they talk about their dual band and gigabytes up to 100 megabit throughput, these are all theoretically true things in a greenfield environment where none of these other factors that we have to consider are there. But when we get into the more complex matrix that is the real world in business with multiple users and multiple access types and multiple devices, we need to have a better understanding and better control on a more granular level about how we steer the traffic, how we address who gets to access what, where, how, and when. And those are features that are only available on enterprise-type devices. You made a good point, Nathan, as well, that the selection of the vendor, the person who's providing the solution for you, may be very dependent on those business requirements that you give us, or that you consider when you're deciding what your wireless solution is going to look like.
Yeah, and I think that one of the things that I always like to throw out when we talk about that too is that there's a lot of marketing information out about wireless access points and about the the number of devices you can connect to an individual radio. And a lot of these devices have, some of the consumer ones only have one radio. Most enterprise class have at least two, if up to 16 radios. And the marketing materials might tell you that you can get up to 50 devices attached to each radio. But based on all the other things that Philip was talking about, as far as throughput and the fact there's a finite amount of bandwidth and all those variables, really you're talking that it's closer to 15 to 20, maybe 30, depending on the type of traffic you're doing. So that's the other problem when you talk about scale and density, is that there's some reality around what the experience is going to be for the end user when you take the number of radios times the number of devices you intend on connecting. And again, that's where the business requirements, as Philip's articulated, are what might dictate, do we need a bunch of radios that have a bunch of access points that have two radios in them that are spread out over a wide range because that's what the coverage and that's what the business requirement is? Or do you have an auditorium of people that you need 300 people to connect all at the same time, and you need a methodology that can handle 300 devices, which might be a different solution and might be a different provider. So that's probably a good segue to the next slide.
Yeah,
the next
absolutely.
Questionnaire.
So we've talked about kind of this complex matrix of different stuff, and again, the business requirements that we've talked about, they're really over on the left-hand side are really just kind of like very big topics, and there may be many other business requirements that come into play, and there are also many other technical considerations that come into play. And I've just listed a couple of them here on this slide, but the ability to grow, how reliable things need to be, what is the timeline in terms of when you're going to deploy things. Do you have a vendor that you're required to use? Does it matter if it looks good, or can there be wires hanging? Can there be big antennas dangling all over the place, or do they need to be hidden where people can't see them? So there are many other considerations outside of the kind of top four we talked about earlier that can really impact what that solution looks like. And this is why planning with regards to wireless is so critical. And that's why Mytech always recommends that we do a site survey in advance, either predictive or actual, in order to identify what the environment looks like and what our needs are, so that we can make a proper recommendation, or that you as the organization know that the solution you're putting in place meets the requirements that you have, and if it is some way lacking in the requirements you have, that you know what that is. So I'm ready to move on here. We have prepared a wireless network questionnaire, and maybe Nathan, I can pass it back to you, and you can go over some of what those items are.
Sure. Please go ahead and pull that up. I know that you have that on your screen there. So we put together these are just kind of this is a questionnaire that kind of gets into the high-level variables. So answering these questions, and combined with a wireless site survey that Philip was just referring to, the combination of those two things will enable us, enable you or us to help you, or you, any other IT provider help you, to find the solution that you want. So we talked about a lot of these things. You know, I won't go through every single question, but I will actually email these out to the attendees today, and anyone who likes it, but who would like to see it. But you know, we talked about the, you know, what is the square footage of the coverage areas, right? Is this a one room, or is this a huge facility, or is this just the warehouse? What building materials are part of the coverage areas? You know, wireless will go through different materials in different ways, right? Or not at all. You know, what may cause, what equipment in your facility may cause wireless interference? This is an interesting one. We've experienced where welding machines or MRIs or other medical devices and manufacturing devices will actually interfere with the wireless and potentially even interfere with the wired network sometimes. So the different devices, what types of devices, again, we talked about how tablets and smartphones don't have as strong of a wireless signal, wireless radio in them as do laptops. But you could also have other wireless devices that are on there. What if you had wireless security cameras? What if you had wireless, you know, barcode scanners, as Philip alluded to? What if you have? There's a bunch of other different. You know, we've worked with an organization recently that has wireless clocks for their time clock practice, right? So there's all kinds of other wireless devices that could come into play with these variables. But going through all these different questions basically will give and answering those questions yourself. Or working through with a wireless expert with those questions, along with the wireless site survey, are the things that can help make sure that you're covering all the different variables. And so I always like, relative to wireless, I always like to point out, for those of you listening, you know, we do this in a lot of our presentations, not all of them, but this one in particular, if you'd like us to spend some one-on-one time with you, digging into whatever the wireless problem you're having or the wireless solution you're trying to figure out, going through that questionnaire, understanding your situation, and providing just whatever advice that we can provide. I'm not saying as a sales call to do a quote. I'm saying that if you just want to be able to leverage our experience and talk about where we see the problems that we've seen happen and how that might help you, we're game to be able to help you out. So we can go through this questionnaire with you. We can go through your exact scenario, spend a little time with you, and share our experience. And if that helps you solve your wireless problem, then great, and then it's a win-win. So, yeah, Philip, any other final comments on that?
No, I just want to say thanks to all of our attendees for letting me speak and share with you today. And again, my invitation to you is I love talking about this stuff. So if anyone wants to nerd out on the side, feel free to reach out to me or Nathan, and I'm sure we can find some time to indulge you in that.
Sounds good. Well, with that said, it's 12 o'clock. And to be respectful of everyone's time, we are going to sign off. But thank you, everyone. I will follow up with everyone, and you'll get an attachment with that questionnaire for your convenience. And by all means, please reach out if there's anything we can do to help. So thanks a lot, everyone. Signing off for September 2014 Mytech U.
Thank you.